This is question number 13, and it gives you a bunch of graphs for your option, and it says which graph below best represents this function, f of x equal to x to the 1/3 times x minus 4, and then they give you the first derivative and also the second derivative. So with this information, we can kind of try to work through these a little bit of these first and second derivatives and see if we can find out any information about the graph and then eliminate some. So our best bet probably would be first to work in the first derivative. We should notice that for f of x, we know that the roots of our function will be 0 and 4. And we look at our graph, and those are roots of every function. So that information doesn't really enable us to cancel anything out. So I'm going to move on to my first derivative because that gives me a lot of information. So I set both the top and the bottom equal to 0. And I get that x is equal to 1 here, and then x is equal to 0 on the bottom. And I know that if I plug in 2, I get a positive over positive. If I plug in 1/2, I get a negative over a positive, which is a negative. So I know that at 1, I have a relative minimum. So any graph without a minimum at 1 gets eliminated. And so that is our, that's graphs A and D. Those get thrown out immediately. Alright, and so then I also know that if I just test a number after 0 at like -1, if I plug in -1, I get a negative on the top and a positive on the bottom, which is a negative. And so my graph should be decreasing as I move towards 0. My slope should be a decreasing slope. And so that is graph, I can eliminate then B, because B has an increasing slope approaching 0. And then the last thing that I would do maybe is look at my second derivative. And I'm going to set the top and the bottom equal to 0. And I get that x is equal to -2. And the bottom it's 0, so I got 0, -2 here for my concavity. And if I test -1, I get -4 plus 8 over a negative, so this is a negative. And then if I test -3, I would get a negative over negative, which is a positive. And so I know that at -2, I should have an inflection point that goes from concave up to concave down. And I can eliminate then graph E because that doesn't have an inflection point at x equals -2. So my answer then is graph C.